What's up, guys? It's Mr. Brangle, and today we're going to talk about direction of acceleration. So quickly, let's review what is acceleration. Acceleration by definition is when an object changes its velocity and or direction over some period of time. We'll focus on velocity today. So notice that did not specify speeding up or slowing down. As mentioned in our acceleration notes, a common misconception is that when we say an object is accelerating, that always means that it's speeding up. Again, by definition, it could be speeding up or slowing down, so we don't want to limit ourselves in that way. Let's take a look right here at these 2 points and to help us out before we start working with this. The 2 really important things that we need to understand is that if an object is speeding up, then the direction of the acceleration arrow will always be in the same direction as the object's velocity arrow. The velocity arrow points in the direction that the object's moving, right? If I have a velocity, if I'm riding my bike, my velocity is pointed in the direction I'm moving, right? And if I'm speeding up on my bike, the acceleration is also pointed in the direction that I'm moving. On the flip side, if an object is slowing down, so if I, hit the brakes on my bike, the acceleration direction will be opposite the direction that I am moving or the direction of my velocity. So if we can kind of get that straight, that'll be really helpful, because once you understand whether the object's speeding up or slowing down, you should be able to pick the direction of the acceleration arrow. So as we do this, for any situation where you need to figure out the direction of acceleration, whether it's a motion map or a graph or whatever, we want to ask ourselves these 2 questions. What direction is the object moving in? If we're using positive and negative, is it moving in the positive direction or negative direction? If it's cardinal directions, maybe it's east or west, or maybe we're just saying left or right. But the direction that the object is moving is really important, because that's also the direction of the object's velocity. The next question would be, is the object speeding up or slowing down? For the reasons that we just talked about. Once I know the direction of movement and the direction of velocity, then I find out, is it speeding up? Great, I'm going to put my acceleration arrows in the same direction as the velocity. Or if it's slowing down, I'll move my acceleration arrow, or point my acceleration arrow in the opposite direction. So let's look at a couple examples here with written descriptions. So the first one says a car is speeding up while traveling north. So the first question is, which direction is the car moving? It's north, obviously. And is the car speeding up or slowing down? It told us that it is speeding up. I'm just going to write speed up like this. And then which direction is the car's acceleration? Well, if the car is speeding up, then that means that these 2 answers here and here have to be the same, right? We said that if an object is speeding up, the acceleration will be in the same direction that the object is moving in, or the same direction as the velocity, okay? Now, looking at the second one here, it says a person is riding a bike to the left. They stop pedaling and let the bike roll to a stop. So which direction is the bike moving? It told us that the bike is moving to the left. And is the bike speeding up or slowing down? If I stop pedaling my bike and roll to a stop, I am obviously slowing down. So when the answer to speeding up or slowing down is slowing down, remember that means that we are going to have opposites here. If the object, or in this case the bike, is moving to the left and slowing down, then that means the direction of the acceleration would be opposite, and that would be to the right. Okay, so fairly simple when looking at written examples. Okay, let's go to the next page and let's talk about motion maps, which will help us visualize this. So on this first motion map, it says, let's draw a motion map for an object that's moving at a constant velocity. So I am going to use green for the velocity, and I will use, red for acceleration. But let's just imagine it starts at 0 meters, and I'm just going to have this moving 1 meter per second for a few seconds. So we're going to put dots 1 meter apart, and remember that the space between the dots represents a second passing, and the length of the arrow tells us how fast the object is moving. The object is obviously moving 1 meter per second in this scenario. When we draw a motion map for an object with a constant velocity, the acceleration arrows don't exist. We will always draw our acceleration dots directly below the velocity dots, but because the object is not speeding up or slowing down, we just leave those dots blank. We're not going to put any arrows on there because there is no acceleration. If an object is speeding up or slowing down, then we include the arrows on the acceleration dots. So that kind of answers this question right here. If an object's moving at a constant velocity, is it accelerating? No, it's got to change its velocity to be accelerating. Okay, so let's predict what a motion map should look like for an object that's speeding up while moving in the positive direction. So if you're watching this, go ahead and just pause it for a second and make a prediction as to what this motion map should look like. I'm going to go ahead and move on right now. So we will start with the velocity in green here, and I will show, it says that the object is speeding up and it's moving in the positive or forward direction. Whoops. And so I'm going to show, it doesn't really matter where you started. I'm going to start at 0 just because, and we need to show that it's speeding up. So that means that it will be covering more and more ground as it goes. So we start with our dots relatively close together, and then they should be getting further and further apart. So we have a small arrow, medium arrow, large, and we'll go ahead and finish this with an extra large arrow there. Okay? Now, what we have to do is we have to then add our acceleration dots directly below the velocity dots, like this. And we'll need to pick a direction for the acceleration. So let's actually answer the questions before we do that. Okay? So it says, which direction is the object moving? It told us the object was moving in the positive direction. Okay? And is the object speeding up or slowing down? It told us that it was speeding up. So that means when the object is speeding up, that means that these answers are going to be the same for this one and this one. We must also have a positive acceleration if the object is speeding up, so that it's in the same direction as the velocity arrows. And what we want to do here, since we're looking at constant acceleration, all of our examples in here will be constant acceleration. We're not going to change the length of the arrows for the acceleration dots. All we're going to do is pick a length, maybe something like this, and we're just going to leave that the same for all of these dots. Constant acceleration will cause the object to increase its speed at a uniform rate, meaning if it's accelerating at 5 meters per second squared, it's going to increase its speed by 5 meters per second each second. Okay, so let's look at one more example here. Again, I would like for you to make a prediction here. What a motion map would look like for an object that is slowing down. So slowing down while moving in the positive or forward direction. So go ahead and pause the video, make that prediction now, and I am going to move on. So for the velocity of the object, it's moving in the forward direction, so we'll start at 0 again, but this time it's slowing down. So that means it was already moving quickly, and then it is going to lose speed, and these dots are going to get closer together. So the first one has a long arrow, medium, short, and then let's just add on a tiny one right here and show that it stops maybe. Okay? Now it says, again, we'll go ahead and write in our acceleration dots directly below the velocity dots here, but we're going to wait and figure out our direction of acceleration before we go any further. Which direction is the object moving? Well, it told us that the object is moving again in the positive direction. Is it speeding up or slowing down? It is slowing down. And when the answer is slowing down, then that means that these are the direction of movement and the direction of acceleration are going to be opposite, so that means that the acceleration must be negative. If this is the positive direction, then that means that the negative direction would be this way. So we need to come back over to our acceleration dots, and we are going to put leftward pointed arrows, again all the same length because we're doing constant acceleration. And this will cause the object to lose velocity at a uniform rate. Again, meaning that if the object is accelerating at 5 meters per second squared, in this case to slow down, it would be losing 5 meters per second of velocity each second. Okay, so this will conclude the first part of the notes on direction of acceleration, where we talked about written descriptions and motion maps. Part 2 will cover direction of acceleration when looking at position and velocity versus time graphs.